Hi everyone, today I'm going to be talking about the urban heat island effect. So, what is the urban heat island effect? The urban heat island effect is a phenomenon in which urban areas experience significantly higher temperatures than outlying areas. This creates what we refer to as a heat island. The image shown indicates noticeably higher local temperatures in areas with more urban infrastructure, as compared to the surrounding suburban and rural areas. This is why you may have noticed that larger cities tend to feature higher temperatures than the neighboring outskirts. As you might have guessed, the overarching cause of the urban heat island effect is urban infrastructure, which can cause a number of subsequent environmental consequences and disruptions. Urban areas have vast stretches of concrete, asphalt, and buildings which all absorb and retain heat more effectively than natural surfaces, like vegetation and soil. As a result, this leads to higher daytime temperatures, as these surfaces absorb more and more solar radiation. Another issue with urbanization that can exacerbate the urban heat island effect is that it often leads to increased impervious surfaces, like paved roads, sidewalks, and parking lots, which prevent rainwater from infiltrating into the ground. Instead, water quickly runs off into storm drains, picking up heat from these surfaces along the way. This runoff can carry heat into bodies of water, contributing to higher water temperatures and also lead to more frequent flooding. So, to demonstrate the way urban landscapes absorb, retain, and magnify the heat emitted into the atmosphere, I've set up a little experiment to simulate the urban heat island effect. The materials needed for this experiment include white construction paper, black construction paper, a heat lamp to simulate the radiation emitted from the sun, which is at the top of the video there, an infrared thermometer that can measure object surface temperature, and a poorly constructed Weeks haul, as you can see in the video. After waiting 5 minutes of letting the heat lamp warm the surfaces, we see that the highly reflective white side is 72.5 degrees Fahrenheit, and measuring the absorbent black construction paper side, we get a measurement of 75.3, so it's already hotter than the white side. And after waiting another 10 minutes, we see that the reflective side hasn't gone up much. However, the absorbent side goes up to 78.2 degrees. So what does this experiment tell us? The black paper is representative of what is going on in our cities, with more dense concentrations of pavement, buildings, and other surfaces that absorb and retain heat. On the other hand, think of the white paper as green vegetation and soil, which has the capacity to evapotranspire, or release water into the atmosphere to cool the air and offset the urban heat island effect. In addition to this, vegetation and soil act as important reservoirs for carbon sequestration, highlighting the importance for adopting green infrastructure and porous pavements into future city planning.